Greetings everyone! Here I am again, and in the upcoming tutorial, I will present one of the most commonly used functionalities, dictionary management. A dictionary is an essential element for both basic and enterprise database management applications. You will soon learn how the Recrogrid framework provides efficient and unique support in this area. Join me on this journey. In the demo, I will use the previously created Northwind sample application, and you can find videos of its creation in the description. First, let's define what we call dictionaries in the RGF, where and how we use them. For example, by examining an entity property, we can see that it contains several drop-down lists. Behind these lists, there is a dictionary. Each dictionary element has a key, which is stored in the database, and may have one or more textual values from which the user can choose. It is worth mentioning that there is another similar feature in RGF when we select from another entity. For instance, in the product entity, we choose from category. In this case, we select from the categories in a grid instead of a drop-down list. By default, related entities can be selected this way. The advantage of this method is that the list can be easily filtered, and it operates quickly even with a large amount of data due to server-side pagination. And now, let's review the types of dictionary management we'll cover in this tutorial. The first two methods will generate dictionaries directly from our existing database using database queries. The next two can be configured on the RGF admin interface, while the last two allow for defining dictionaries at the code level. Let's start with the native SQL method. Here is the category field, which currently uses the entity selection method. However, as there are only 8 items, I will replace it with a drop-down list for easier use. For using dictionaries, you can find a guide on the RGF website. This exact example is provided there, which I will now copy. I will select the product from the entities and modify the previous category name field. The form type will be drop-down, and the value should be bound to category ID. In the optional settings, I will define the dictionary elements. NSQL means this is a native SQL expression specifying the key value pairs. And that's it. If I check the form view now, I can see that the drop-down list appears. This modification also affects the filter, allowing us to choose from the list items here. This filtering is executed server-side at the database level. I have defined this dictionary directly for a field, but it's also possible to create it globally, allowing the same definition to be used for multiple fields. To do this, I will create a new entity with the category set to NSQL. And define the query here. I will specify the entity in EntityBase. So the field-specific dictionary definition is no longer needed. Let's try it. Everything works perfectly. If we want to use a dictionary based on another entity, there's an even better solution. We can prepare the entity itself as a dictionary. To do this, we need to define in an option within the entity how it can be used as a dictionary. We need to specify the two columns we want to use as key value pairs and optionally a third value for sorting. This method allows us to specify this entity in EntityBase. That's no longer needed. Let's try it. Everything works perfectly. These were the dictionaries created directly from the existing database. Next, we'll explore how to create dictionaries not defined in the current database tables. For the example, I'll create 4 new columns in the category table that we will use for these dictionaries. These will be simple int values, which are not required. I'll quickly create a migration. The database modification will automatically occur during the application's execution. In the category entity, I will add a new property called dropdown static. Its type in the list will be string, and it will appear as a drop-down list in the form view. It should be readable, editable, and displayed on the first tab. I will copy the dictionary elements definition from the example. This is a simple JSON format listing key value pairs. Since the field is not required, I will define it as such. With this setting, RGF automatically adds an empty value to the dictionary. Let's try it. Here is our new field. I will modify the value and save it. This field can also be filtered. Of course, this is also done at the database level. The next dictionary method is reproduct. This is perhaps the most useful method among all, allowing us to define a multilingual dictionary on the interface, which RGF will display based on the currently used language. First, I will define the dictionary itself. The scope determines the dictionary name, the string key, and the others the text to display. I'll quickly define 3 items. I will add a new property with the usual settings. In defining the dictionary elements, I can refer to the rekrodict using this special format. The drop-down rekrodict itself is the scope. This field is also not required. Let's try it. Let's check the filter as well. Everything works perfectly. Another common case is when we need to choose from enum elements. Let's look at an example of this. And now I will add this field to the entity as well. In this case, the elements must be defined with the enum prefix, specifying the enum's assembly qualified name. This field is also not required. Let's try it. This also works perfectly. You can also specify a display attribute for the elements, which RGF will use for display. This will appear in the grid, form, and filter. Similar to NSQL, the enum dictionary can also be specified at the entity level if we want to use it for multiple properties. In this case, it takes the dictionary elements based on the entity base. The result is the same. For enum cases, another interesting solution is when we take the display text from a rekrodict dictionary. This should be defined in this format. It is evident that the textual display now comes from the rekrodict, as I defined the rekrodict keys to match the values in the enum. Okay, I'll revert this change. The last method we'll look at is a commonly used solution in other systems, the callback. In this case, a function is called before the list is filled, which has to return the dictionary. This function should be placed in the retrogrid or the entity model class. I'll make a new build. Finally, I'll add the last field for the callback dictionary. The definition is the callback keyword and the function name. Let's try it. Also the filter. And now we've reached the end of the presentation. I hope you found the demonstration useful. If you liked it, click the like button and check out other retrogrid framework content. Thank you for your attention.